Let's talk about how we might do this review. So number one, we have a recursive definition. It's going to start at 210. Oops, sorry, that's wrong. Let's put the 210 over here next to it. And that would be at 0. Then 1, 2, 3, 4, 5. And according to this part right here, to get the next term, we should subtract 30 from the previous. So this will go down to 180, then down to 150, 120, 90, and 60. Okay, let's look at a graph of that. Let's make this as easy on ourselves as we can get. So if I define a corner as 0, 0, okay, and I gotta go out to 5. So maybe 1, 2, 3, 4, 5. Going vertically, I have to get up to 210. So how about every 4 is 100? So that's one way we could do it. And then we'll just put the dots on there. Just approximately where they would go. We don't have to get it exact. And oops, I just didn't use my scale, did I? So let me label this on the bottom. This is 1, 2, 3, 4, 5. So that should have been 180, somewhere around here. 2, 150. 3, 120. 4 is under 100. And 560. So right about here. So this is the n-axis, and sorry, that is not right. This is the n-axis. This is the f of n-axis. The domain is 0 through 5. 0, 1, 2, 3, 4, 5. Does sort of seem to want to go on forever, right? So a little dot, dot, dot on the end. And the range, if we just kept going down, we would have eventually got to 0 and 30. So I'm going to go ahead and pick this one. Definitely wouldn't do C or D because those are continuous. The story, I don't know. What could that be? So I had 210 friends, and every day I block 30 of them. I don't want any more friends. Okay, let's look at this next one here. Bill has a collectible baseball card with $100. Its value increases by 5% a year. So right away I'm thinking that's 0.05. Its value is going up, increasing, so it's got to be 1.05. Create a table based on this information. Instead of X and Y, write appropriate variables for the columns in the table. So this could be years and value. So we'll start it at 0. And we will have in between values here. This is going to be $100 and then 105. Now after that, I'm going to have to use a calculator. So let me pull that up. All right, so 105 times 1.05, it looks like it's 110.25. And then do that again, times 1.05, 115.76. And I have some other decimals there, but I'm going to leave them in the calculator. It will be more accurate this way. And then one more time, 1.05, $121.55. Okay, so we're going to do another graph. So 1, 2, 3, 4, 5. Ought to be enough. And on the y-axis, I want to go above 100. So let's try to make it easy again. How about going by 20s? 20, 40, 60, 80, 100. So how about every 5 is 100. That makes every square worth 20. And then I have 0, 100. 1 is at 105. So it's still going to be pretty far down. Kind of questioning that, whether to make the scale bigger. But, oh well. 2 at 110. You're not going to see much difference here. It's too small. 115 at 3. Yeah, because I'm not even going to get up to the first line here, barely. And then 4, I'm barely over that first line. So it does curve. I do not like my scale, but I'm going to have to live with it. And so the x-axis would be years, and the y-axis can be in dollars, because that value was in dollars. The domain is everything after 0. So 0 to infinity, although I don't think this baseball card will last forever. And then let's see, the range that would go with that couldn't be A or B, because those ones are discrete. It does start at 100 and go up. I'm not sure we have the answer here. On the range, I think it was supposed to be this one, but it should be written as 100 and then going to infinity. Oh, let's call that a typo on that one. Or maybe they meant it to be D. And, well, either way, this is the answer. Write an equation, so f of x is going to start at 100, go up by 5% to the x. Okay, let's take a look at the back side. All right, that negative exponent means to flip it upside down. So if I just do this, okay, I've taken care of the negative. And remember, 3 is just 3 to the 1. Okay, now I'm going to subtract exponents. 4 minus 1, so there'll be 3 3's left over on the bottom, and the top is going to turn into a 1. And if you're stuck, just write it out the long way. 1, 2, 3, 4. And then you see it starts canceling. And that's it. So then there's 3 3s on the bottom and 1 on top. For b, I can take y to the 3 times 4 12th power over y to the 5th. 12 minus 5 is going to be 7. You're going to subtract exponents there. There's a negative exponent, but I can add to begin with. I can just go 2 minus 6. 2 minus 6 is negative 4, and then I'll just flip it. I'll invert it like this. And let's see, d, if I add 5 minus 5, I'm going to get 0. X to the 0 is actually the number 1. Okay, almost there. Last problem. Okay, here's the function. Time on the x, floors on the y. Looks like I'm going from the 12th floor down to the ground floor. So the table would start 0, 1, no, actually. Yeah, 0, 1, 2, 3, 4, 5. And then the y, looks like we're on floor 12. At 1, I would just have to approximate that. It's about 10 and a half. And at 2, make this pen a little bit smaller. 2 looks like it's at 9. 3, it's about, I don't know, 7 and a half. 4, it's at 6. And 5, 4 and a half. What is the domain? So look at the whole graph. It's going from 0 to 8. So 0 on this side, 8 on this side, okay? And I'm going to put a comma between them. So from 0 to 8, and the range is going from, remember it's still lowest number to the highest number. That would be right here. That's 0 to 12. 0 up to 12. Okay. Now let's see how we would grade this. Oh, one more. Write an equation for the given graph. Okay, so let's see, what variables? X and Y. So Y equals, it starts at 12. Okay, now I got to figure out the rate of change. It looks like if it goes, so if we go down 3 floors, then we've covered 2 seconds. And so how about negative 3 over 2? See, because it works here again, down 3, down 2. So it's basically 1.5 floors a minute, which you could do if you did like 12 down to 10.5 and then 0 to 1. But if you want a fraction, it would be something like that. Okay, let's see. How would we grade this? Well, I think we would probably do 1 point per part. So on number 4, we have 5 parts. No, 4 parts. 1, 2, 3, 4, 5. Yep. And then 5 parts on 3. So that's a total of 9. And then 1, 2, 3, 4, 5 parts again. And 1, 2, 3, 4, 5 parts again. So it looks like there would be about 19 different parts on this. And so if I give you a point for your name, then that could be a 20-point quiz. Okay, so we'll see how you do.